Hello guys, thank you very much for coming over. We hope that you're enjoying as much as we're enjoying this place. We would like to tell you more about our reactive infrastructure for functional code. It's not a limitation of this infrastructure to run only functional code, but we think that this is quite appealing case. My name is Radek Ostojski. I'm heading infrastructure in Addison Global, and this is Marco.
I am Marco Giovannini, infrastructure engineer in Addison Global.
We would like to tell you more about our infrastructures that we built it from scratch in last 18 months, and let's see how it goes. So this is our landscape. In our landscape, there's a lot of icons, but why we would like to show you this? We would like to tell you that the complexity of this picture means completeness of the solution, and why it all makes sense all together. First of all, treat it as a map of our galaxy. It's not the only galaxy in our universe we have, but it's one of our favorite one we have to show you. 2 years ago, when we just started, we've got some ideas, primarily what's usually going wrong, and a few strong ideas what we really need to make right this time. And we decided to follow reactive patterns in architecture. So the reactive patterns in architecture giving us flow-tolerant ecosystem, and later on even more fault resistance ecosystem. For that type of environment, we choose cloud. Being cloud native sounds like a best solution we could find it on a time. Marco will tell you more about the focus on...
So to follow this concept, we focus mostly on 4 ideas. One is automation is key for us. We store all our infrastructure as code. This allows us for every single change in the infrastructure, the engineer is able to deploy from scratch the entire infrastructure or part of it in his own dev account. So he's able to develop his changes in code, be able to deploy it, test it, and is going to be able to merge it. The second feature is isolation. Not only from an application point of view as feature isolation, but from infrastructure point of view. We know the things are going wrong, and we design our infrastructure to handle the failure. So we will have less surprise. Extensibility through modularity. Every single piece is a module. This allows us to swap out a module and replace it with another one, as technology evolves with it. One typical example is our Kubernetes platform. 14 months ago, when we started to build it, there was no available service in our cloud provider. So we had to build our own in the hard way. As soon as we go through reevaluation of the technology, our cloud provider provides a solution of it, and now we are swapping out our Kubernetes from scratch and replacing with the managed solution, so we can focus on much more interesting thing to do on top of it. As we probably know, managing ETC cluster or Kubernetes infrastructure is a challenge. So if we can handle to someone else to do the boring stuff, we will. So the last one is the elasticity. Whoever is going to tell you that is able to know how much capacity you are going to need tomorrow, in a week, in 6 months, probably is lying to you. Nobody will be able to see in the future. So we approach the infrastructure in another way. We instead of guessing how much capacity we are going to need, we use components that are very elastic by design. As you can see in our design, most of the components, on the major component, are going to scale horizontally without we having to guess what is going to be needed by tomorrow.
That's right, even more. In our case, the loads comes and goes very rapidly. This is why this infrastructure is so cool for us. Let's talk about what we don't need to care so much. Let's talk about cloud ingredients that we are using. There's quite a lot of them. Marco, again, will give you some ideas. What does it help us with?
So as infrastructure team, we do not limit the introduction of new technology. We try to find the best technology to solve our problem in the most efficient way. This is a very interesting thing because you are able to play with a lot of things. Sometimes will stay with you in dev, sometimes they will they will reach prod. Sometimes they won't. But this is very challenging, especially if you have a small team. This overhead of the operational cost can burn you. So for this, we follow two gold rules. The first thing is we don't want to reinvent the wheel from scratch. There are a lot of interesting challenges to solve it, and we don't want to solve it over and over again. And the second point is we want to stand on the shoulder of the giants. So if can offload some of the boring tasks like updating, upgrading, patching, backup to someone who does already it for ages, then we will. So we will focus our idea and our mind on solving more challenging and more interesting things. In practice, this is translated in a simple word, a couple of words actually, which are managed services. So we offload all the part of the operational to our cloud provider.
In this case, what does it help us with? Different things like software development life cycle. It's giving a lot of visibility. Essentially, you're giving a lot of control going to the cloud. But fortunately, with mature cloud solution, you have some visibility back that giving you some control. You have also a lot of tools on ops, security, connectivity. And let's talk about our main hero of today. This is what we're calling Reactive Environment. Reactive Environment is very special to us. This is the local solar system when the code is living, but again, it's one of the components of our galaxies.
So what we call reactive environment is actually the environment where all the application business run on. As you can see in the picture, is mostly based on 4 layers. On the top one, which call with the edge layer, is where are the components that provide service to the outside world, mostly through our API or through a content delivery network where mostly of all front end is stored. In this case, we use the CloudFront from AWS. Just below that, there is our messaging bus. So we use it Kafka for it, and this is a very great tool for us because it's scaling horizontally, but in conjunction with the AWS, we are able to spread the cluster across 3 availability zones. And together with replication, which is availability zone aware, we can guarantee that 2 copies of the data, they are never in the same availability zone. So in this case, we are able to lose an entire availability zone, and we will not even notice it. Just below it, there is our computing layer, which is based on Kubernetes. This one is still built from us, built from scratch, not using COPS or other tool, because we wanted to have a really flexibility of how we are going to configure it. We have our Kubernetes is the control plane, again, is spread across 3 availability zones. So it's in a HA, and on top of it, there is a load balancer. All the workers are connecting through the master, through the load balancer. So we will be able to lose master, even 2 of 3, and we're still able to handle it properly. So, and Kubernetes take it the responsibility to manage our pod. We usually run with replication 3. We cannot guarantee that they are all on different zones, but Kubernetes will take care of responding it if there is any problem. The last one, but not the least, of course, one of the most important layers is our data layer. Now, we are using 2 types of technology here. One is a more traditional relational databases, but in this case, we offload all the management and all the boring stuff to the cloud provider, so we can focus on the data management. So for us, the cloud provider does the backup, we can restore it from it, he can take care of the upgrade it, and so on. The other one is a Cassandra. Our Cassandra follow exactly the same approach. Is a distributed system by design, but in conjunction with the AWS, as is zone aware, we are mapping a rack to an availability zone. So having a replication of the data, it will be guaranteed that it will be across availability zone. So we will be able to lose 1, or depend from your query consistency, 2, availability zone. If your consistency, of course, is 1, you need only 1. If it's quorum, you need 2 of the 3. These are just the core services, but we have only around it an ecosystem of services that we are using it. And Radek will introduce this.
So let's talk about satellites. Marco mentioned that Cassandra and RDS is very important for us. Of course, you want to save your results somewhere. You don't want to compute over and over and over again the same results, but it's not always the record in a database. You can also save it as a file that later on will be served over CloudFormation through CloudFront. We're saving all of that in S3 Origin, and automatically is picked up by CloudFront and distributed. Funny story, it was actually first service we wrote it in this environment. This service is very handy for all the marketing guys who can publish whatever content they like anytime. S3 origins can also be used as a origin for all the other mature CDNs, so you have a lot of flexibility moving on there. On the other side of the picture, you have a lot of green icons. That green icons are primarily security services. Security services are very special. Since so many zero-days vulnerabilities, they work to do as much as you can to secure your system. Ain't not funny when someone jailbreak your VM and go to the database, and it's really rolled to the hell if database is not encrypted. Thanks to services like KMS, which keeping key for all the encryptions we have, we can secure the system, which giving you automatically GDPR compliance. As long as you're making sure that keys are secure, nothing can happen. ACM is the place where we're keeping all the certificates. It's automatically taking care, renewing SSL certificates. IMI policies, tidying up all the places, all the access APIs you have there. Other services we have on the picture, like Logflow and ECR, that are really supporting our workload on software development lifecycle. But let's talk about sidekick of our hero, infrastructure VPC. It's something that we build it for connectivity primarily. It's, oh, sorry, wrong slide. Here we go. It's something that we build it primarily for connectivity. One of the problems that we're facing in our industry is that it's not always the call from clients that we need to process. Quite often we need to process something over VPN connectivity, whitelisted IPs, you name it. And what's going on in that kind of situation when you have environments that you want to upgrade to the new environment, you really need to work hard on your connectivity. In our case, connectivity is centralized in a place that it stays there, that is always giving the full access. Same place where we're keeping CI/CD infrastructure, where we're keeping automation, backups, and when we're giving a lot of visibility through Prometheus and Elasticsearch, which Marco will tell you more about.
So observability for us is a very important thing. You know that on distributed system, it's a very hard and very challenging thing. And we knew from day one that this was one of our core ideas. In a cloud environment, instances come and go very often. But if you put on top of it a Kubernetes and container, they come and go even more often. So for this, we have to observe our infrastructure and the application itself. So we do providing two major systems, the metrics management and the log management system. From day one, we understood that we didn't want this to be so the developer need to be used out of the box, and this is what we did. So these two services come out of the box, and developer has just to agree on a couple of things to make use of it. One is our metrics platform, which is based on Prometheus, which require from developer only two requirements. The first one is, of course, they have instrument their application, and the metrics has to be on the Prometheus format. The second one is adding a couple of annotation to their pod, where they configure what they want to scrape, for example, the endpoint, the port, and if they want to scrape it or not. Prometheus will take care of automatically discover any application that is running and pulling this information from the annotation and configure the script automatically. So in the matter of few seconds, as soon as the pod is on and Prometheus discover it, you will have your metrics available in Prometheus, and you can graph through to Grafana. The second idea, which follows the same similar pattern, is the log management. So here we have even more requirement for the developer. The only requirement that we have is they have to log in standard output, and that's all. Out of that, the log will automatically capture from the Docker driver, pass down to the host, stream it out through FileBit, which will go through an Elasticsearch, a Logstash cluster. We will do all the transformation, and it will be available in Elasticsearch to be visualized through Kibana. Now, there are another part of the log management, which is the network part of the logs that Radek will introduce.
So it's kind of interesting because when your application doesn't log anything, you don't know what's going on. You're trying to send a request, but nothing happening. It could be the case where your request just never reached the server. And in this case, you really would like to know. And in our case, you can get that information using VPC log flows. However, by default, they are in completely different systems. They are in CloudWatch logs. What we did recently, we enabled integration between CloudWatch and Logstash. So all the data, including network metrics information, you have in the same place over Kibana. So far, you heard quite a lot of what we're doing. We zoomed in, we zoomed in. Let me tell you how we're doing certain things to show you that we're actually doing not much different from being developer. We're using exactly the same tools. We probably secretly are a little bit of developers in our hearts with the ops part. We're using declarative code as much as we can. We have CloudFormation templates, we have Ansible playbooks, we have Kubernetes manifest. We're testing, we're doing regression, we're doing all the rituals that normally you have in development teams, like we're working in a sprint to sync with other teams in development. And we're growing with the different directions. So how this happens, like someone has a brilliant idea, happens that it needs to be put in a Jira ticket, happens that it needs to be discussed during planning, grooming session, we're putting into the sprint, there's a happy time of coding, there's an even more happy time of exporting all of that stuff directly to the S3 buckets where you get ready to deploy. After we're merging all the code together, where we're doing extensive integration tests, we're putting all the stuff, we're making fun on each other and on each other code. That's happened quite often. And finally, we're building, when they come, update on the infrastructure of each environment. We're updating each of the environment to be in exactly the same code, so there is no difference as such except capacity between dev environment and production environment. And this is the end to be beginning for the next cycle. In the next cycle, we're doing either something new, or we're changing some stuff in the processes, or we're discussing what went great, what went not so great, and what we can improve it. So let me tell you what we're working right now. Right now, we are really focusing on making sure that everything is in a code. So far, I think we have like 90% code coverage in automation. We're making sure that as many things as we do, we're running on containers whenever it makes best sense. We're exploring Kubernetes ecosystem. As Marco mentioned, we're moving to EKS, which is the managed Kubernetes, and we're building pipelines for infrastructure. What else we're gonna do for the next several months, we actually don't know exactly, because all the development is a part of discovery process. We're coming with the open minds to each process we're supporting. We're coming to the open mind with each development we're doing. And this is how we're keeping. Sometimes you're typing some code, sometimes you're finding that is incomplete, that you're changing idea, you're refactoring, and you're moving forward. And same time, we're running the ops life, where uptime is the most important thing, especially on a production. How it works in details, you can find out asking us as many questions as you like. We will be still here for quite a few hours after. And what can I tell you? If it sounds cool for you, visit us, talk if you didn't yet, and we're hiring if it sounds cool to you.
Thank you so much. Is there any question? So, what is the minimal setup of your solution?
So we have a different setup from dev to prod. So on dev, we have, from an architecture point of view, they're exactly the same, just in a smaller scale. A typical example is we can run a VM on M5 X large or 2X large, and in dev, we are running on small or medium instance example. But there are, depending on the trade-off, of course, you want to do. So less VM, especially for things that work on quorum. So it can be from in even, or if you don't care about quorum, in even part. So let's say you can have one for every, so you can have one ETC, one Kubernetes, one master, and one slave, or worker, you want to call it, and it will be 3 servers for the dev environment, or in case we have more. But the idea is we don't have any limitation, so we can grow and scale up and scale down any component based on the expectation. So there are cases where, example, for our CI platform, where we need to scale up automatically up to 12 workers, and there are days where, I don't know, bank holiday, we scale down to 2 Jenkins or 1 Jenkins.
What kind of server?
Sorry?
What kind of server needs your solution?
It's important to say that that architecture actually is scaling horizontally. We're using primary T2 because of the effectiveness, but we're using M5, which is like new Xeons with memory and CPUs for all the other loads, 16 gig.
So I say we count more on not try to guess it, but try to, for infrastructure to be elastic to grow when it's needed.
Thank you. Any other question? Yeah.
Thank you. First of all, thanks a lot for a very good presentation.
Sorry, I cannot hear you.
Hello. Am I audible now? Yeah.
Yes, thank you very much.
Thanks a lot for a very good presentation. I would like to know that when you are using the AWS cloud, right?
Correct.
For your applications, are you facing any sort of challenges when pumping data towards AWS?
Plenty. Every infrastructure you're building on someone else's system give you some limitations. In our case, we're finding that limitations all the time. Some of them we're solving, some of them needs to be revisited. One of the recent cases we have is that API gateway doesn't really match greatly to our infrastructure, so we will be looking for the new solutions. There's a lot of solutions that has just, let's say, ongoing problems with configuration, and AWS solving that problems in some point. But there are some tools that obviously won't fit this infrastructure. Nevertheless, I think that doesn't matter which cloud provider you will go, you will find this or different obstacles moving on the way.
And the idea of the modularity gives us a lot of flexibility on this. So we are not bound to almost any technology, so we can take it out. So because the only way to know and learn the limitation is just trying it, and that's what we usually do. So we do not try to spend the next 6 months to gathering the requirement. We try many different technology, and sometimes they fail, sometimes they succeed, but we are always evolving and swapping component in and out based on what we figure out on the way.
Okay, thanks a lot.
Thank you.
Thank you.